Welcome back, everyone. We are now going to discuss hub and spoke network topology in relation to our discussions on network peering. In this lesson, we will start with an overview of the need to properly plan peering multiple networks in advance and the consequences of not doing so, from which we will discuss the overall concept of the hub and spoke topology, and then we will take a closer look on how to enable spoke-to-spoke network communication in the variety of ways we can do so. So jumping on into it, let's start with a quick overview of the importance of planning out your network infrastructure, especially as your network implementation grows and you have to peer multiple networks. So when discussing larger network implementations on Azure, especially when planning multiple networks, planning it out is really important. In fact, a failure to plan multiple peered network infrastructure can just simply lead to chaos. So here's what I'm talking about. When you first start out, you may have only 2 or 3 Azure networks that you need to connect together. Well, planning really isn't that important because you can just simply create a single peered connection between 2 networks. Not that big of a deal. However, as your network implementation grows, you may start adding on additional virtual networks, maybe in different regions all around the globe, and you have to be able to connect those networks as well. You may start to see the issue we're starting to get into at this point, especially given the key restriction we've discussed that network peering is non-transitive. As time goes on, as your network infrastructure continues growing, well, you may be adding on more and more networks, and you have to peer those additional networks, none of which can transitively peer with each other, and, well, you have a little bit of a mess you got to deal with at this point. So what can we do about this? One best practice that Microsoft recommends is to have one single virtual network that acts as a central point to many other networks, and this is known as hub and spoke network topology. So what is hub and spoke network topology and how does it work? Well, the name comes from the idea of a wheel in which you have a single central hub in a wheel and you have multiple spokes all connecting to that central hub. With our network topology, the exact same concept applies, in which we have a single central hub network, shown here as hub VNet, which connects to multiple spoke networks, shown as spoke 1, 2, 3, and 4. In this model, you have one central network which is connected to every other peer network that we care about. Some of the more popular use cases of hub and spoke topology include creating a central network virtual appliance or Azure Firewall service that directs traffic to and from all connected spoke networks, and this is officially known as service chaining. Another use case is to establish a central hub network which uses the Azure Bastion service as a centralized host control point for private access to all your spoke networks. And a third popular use case is to provide a centralized VPN network gateway to enable transitive VPN peering to all spoke networks. Notice a recurring theme in all these use cases in which centralization is the primary benefit of our topology. And that's really how the hub and spoke topology works. Again, a single centralized point which can then connect to multiple peer networks, all going through a central hub. Moving on, let's talk about how connectivity works in this hub and spoke topology setup. Going back to the example on the previous slide, we have a central hub with multiple spoke networks directly attached to it. So how does everything communicate with each other? Going back to our previous discussions, we know that each spoke network can directly communicate with the hub virtual network. However, what about spoke-to-spoke communications? Well, our primary rule of transitive peering, or the lack thereof, doesn't actually change here. Each spoke can directly communicate with the hub, however, the spokes cannot communicate with each other. Because, once again, network peering is non-transitive. Rather, if we want our spoke 2 network to directly communicate with spoke 3, we actually have to create an additional network peering directly connecting spoke 2 to spoke 3, in addition to our hub and spoke model directly connecting to our hub VNet. Keep in mind, though, that you are limited to 500 network peerings within a given virtual network, so for very large implementations, this could also be a possible limit. So with that in mind, let's talk about 3 options we have available for enabling spoke VNet to spoke VNet communications. Overall, we have 3 options available to us. The first one we discussed in the previous slide, in which we simply create a separate network peering between spokes. A second option we have goes back to our previous discussion, in which we can create a VPN gateway to route between spokes. Because, as we discussed in a previous lesson, you can combine VPN connections with network peering connections to enable transitive network peering, although there are a couple caveats with this, in which using a VPN gateway between virtual networks leads to overall higher latency, and that traffic does leave the Microsoft backbone, so it is not a perfect solution by itself. The third option, which requires additional configuration and is that exception to the rule I hinted at earlier in this section, is when using a network virtual appliance to route spoke traffic to a hub virtual appliance, which can then go through the additional step via that virtual appliance to then forward traffic to our other spokes. How this works in our example hub and spoke topology is that we have a virtual appliance or the Azure Firewall service hosted in our hub VNet. And in this configuration, we will create custom or user-defined routes which will route spoke network traffic to our virtual appliance, from which our firewall or virtual appliance will then go through the additional step of forwarding that traffic to our other spokes. Again, the default network peering behavior does not change in that it is still non-transitive. However, a virtual appliance can be configured with custom routes to take on that additional duties of enabling forwarding traffic from one spoke over to another. That is that exception to the rule I talked about earlier. With that, this will conclude our discussion on hub and spoke network topology. Let's quickly review our key takeaways before we move on. We discussed the primary concept of the hub and spoke network topology, in which we have a central hub network, which, just like a wheel, have many spokes connected to it, which is ideal for a variety of centralized management and routing scenarios. We then talked about how to connect these hub and spoke networks, in which the hub can directly contact or communicate with every single spoke network. However, for spokes to be able to communicate with each other, by default, we need to create a separate peer connection directly connecting those spokes. And then finally, we covered the variety of spoke-to-spoke network communication options, which include, from the previous point, creating a separate peer connecting one spoke network to another, using VPN connections to enable transitive communication from hub to spoke, and then also creating custom routes to forward traffic to and from a virtual appliance to enable that spoke-to-spoke communication as well. That's going to go ahead and wrap up this lesson. Let's go ahead and move on to the next one.